All right, let's continue with problem 4 through 7. I'm only gonna give you a little bit of hint for each problem. Okay, so this problem 4 describes a gate that stands here with a 6 feet height, and the way the problem is asked is a little tricky. It says if the resultant hydrostatic force acts 2.5 above the bottom, it's collinear with the applied force F. That means that if the resultant force is here, okay, where what does H need to be? Okay, this is almost the same problem we talked about in class, but it changed the unknown. Normally, you know you're given H, you're trying to figure out FR, but this time you're given the location of FR and you're supposed to figure out H. So that's an interesting problem. That means you can't go all the way straight forward from H and solve for FR and its location. You have to set up an equation, okay, and solve for the unknown in the equation. So again, there are two ways of solving this problem. There are two ways. One is you can do YR is equal to Y of centroid plus IXC over Y C times A. Okay, for this problem, that's probably easier. Okay, this is probably easier. We know what these IXCs are. You know YC, you know A. We can solve for H. We can solve for H. Why? Because YR is a function of H. Is H minus, okay, because if this is 0, go down here, this is 2.5. Okay, so Y of R is H minus 2.5. Y of C is H minus 3, right? So those unknowns show up here. Okay, actually the H in here and the H in this guy would cancel out, but you have another H in here, so we can solve for it. Okay? However, if you want to do the fruit ninja approach, and that's also fine. That's also fine. We know we have a pressure prism, a trapezoid pressure prism that can be split into two parts, right? And what we know is that if this is F1 and this is F2, we know that F1 is equal to gamma times H minus 6, okay, times that area, right? Times the area. The area is 6 by 5. F2 is half of gamma times 6 times the area. Okay, we know these two values. And then because they together would form FR, we first know that FR is equal to F1 plus F2. And then, because of moment balance, okay, the moment balance, that's this 2.5 feet condition, F1, okay, times 3 feet, because F1 acts through the centroid of this gate, times 3 feet plus F2 times 2.5 feet, that will be equal to, okay, F1 plus F2 times 2.5. In fact, you see, you can actually solve this problem a bit smartly, but I left it here. So basically, you have this equation where you can figure out what H is. Oh, please do not mind my kids. They are staying home and they're bored and they're gonna make some noises. All right, this problem number 5, it's actually asking about the resultant force acting on this surface. On one side, okay, that's pressing the paper this way. It's asking that. Sometimes people aren't even sure what they're at. The problem is being asked. If we split this into two parts, okay, and I believe actually maybe what is not clear is this height from this problem. It should have a 4 meter here. Right, I think it's kind of implied, but it should have a 4 meter here. All right, so we have a, for this part, we have a centroid here. This part, we have the centroid here. All right, I believe for part 1, it is easy. For part 1, it's simply, you can find what that centroid is. That is easy. Okay, for part 2, that is maybe not as easy. Maybe not as easy. Well, think about this. If you read the book for a triangle, you can find out that the centroid is actually a third from this low side, from this wide side. Okay, 2/3 from the narrow side. All right. Therefore, for the part 2, it would be the location of this would be 4/3, because this length is 4. 4/3 times gamma times the area of, okay, times gamma times the area of this, which is that one. Right? Then, however, why is it this? Let's say you did not open the book and you don't know, you can't find this equation. Why would we have 2/3 from the narrow side? This is actually the same rationale as our pressure prism, right? In the pressure prism, we know that the FR is located 2/3 H, okay, from the narrow side. We know that. Okay? This is mathematically the same reason. Although here we're asking about the centroid, the area integral. It's really the same as this pressure prism problem. Okay, it's really the same. That is, if you do the integral, okay, if you do the integral, you will get 2/3 from of H from the narrow side. Okay, same problem. All right, so problem 6, really a very standard problem. You can figure out what HFH and FV is by figuring out what are the forces on the other side, and do not forget about the weight. I think what is not discussed in classes is, well, this force passed through point A. So think about this. At every point along this curve, okay, what is the direction of the force? What is the direction of the force? Every point along this curve, it's perpendicular, right? If it's perpendicular to that area, it passes through A. So if every point passes through A, then the overall resultant force also would pass through A. And it's not something we talked about in class. That's why I give you the answer here. Okay, this problem, the last problem, number 7, we can see that it's another interesting problem, because this resultant force not only it depends on H in 2 ways. Okay, it depends on H in 2 ways. You have an FR, but you also have a weight, okay, that's pressing down. Now, the width of this is no longer negligible. If you neglect it, it cannot keep its balance, okay? It cannot keep its balance. So there's a little bit of arm length between this weight, where this weight is, to, let's say, if we put that as our axle, right? Therefore, that weight times this distance would be the moment offered by the gravity of this member to keep it steady. Oh, sorry, actually, not this point, but this point. Well, think about your life experience. If you're pushing it this way, the axis around which it will rotate is this point. Okay, it's this point. All right, so our weight has a little distance from that axle point, and that is 8 inch. Note that this is inch. You gotta divide by 12 inch to get feet. All right, that's the weight. That's the moment provided by the weight. The FR goes this way. Okay? The FR, so we know what FR is. Okay, it is half. It is half of H times gamma, right? But the area also depends on H. right? The area also depends on h, so it's h times the length. Okay, we don't know what that length is, and it actually doesn't matter because the length will be in the weight equation as well. And then your moment is Fr times a third of h. Okay, in other words, your h here would be raised to the third power. It would be raised to the third power. For the weight, it is 4 feet. Oh, okay, it's 4 feet long, 8 inch. Then you times the weight, which is the specific gravity is 150. All right, 8 inch, and then you times multiply by the length. Right? And the arm length of this weight is 4 inch, 4 inch over 12. So that needs to equal the moment by this resultant force. And you solve the equation, you get h. H is raised to the third power. So that's it, folks. Hope you enjoy a snow break.